Hi,
Hey, Jawad, good morning. Hello, Anu. Good morning.
Hey JP, hey Jawad.
hey, Anu.
Hey Jawad, I sent you a text yesterday, something about the link layer group. Could you advise on
Uh,
it?
let me see. I think, Anu, I forgot to call you back.
Okay.
I think sometimes you just roll things under the rug. And there's a common disclaimer that we should be telling every work stream that is,
Uh-huh.
please do not share
Yeah.
anything uh, proprietary with us, because if they do, it's their problem, not ours.
Yeah, I didn't know this was happening. I was listening to one of the recordings
Yeah.
and I saw him sharing, and maybe everybody on that call was part of the consortium, so maybe it's okay, but people listen to the recording.
But you see, we don't have enough information to determine if there was any issue or not.
Yeah.
There may not have been any issue. So I think our point in every work stream is OCE work streams are open to public.
Yeah.
Please do not share confidential information here.
Okay, will do. I'll just I'll message Brian and Helia first just to make sure they're aware of it. That's the only team I've seen this happen in. So
Yeah.
thanks, Yuval. Sorry, JP, I was talking about something else.
Oh, no worries. Yeah. I think, hey, Mark. Um, so I think we have a quorum. Let's get started. I just want to get a recap what we actually looked at last time, and then we want to kind of arrive at an agenda, how we want to pursue this work stream further, right? So last week I reviewed some of the work that we accomplished in the POC work group. That we developed the Mara baseboard, and then we developed the package, and then we were actually working on a common universal test board for chiplets or any test chip that can be useful across the industry. These are three projects that we either did or working on it. And I think we need to set a direction going forward, what we want to accomplish further with this work stream, right? So any thoughts on what we discussed last week? Any feedback?
JP, one thing that stuck with me last week is
Hmm.
where the POC team started. Right, one of the ideas to kind of I think you mentioned workflows and integration of chiplets and things like that, and I mentioned that CDX has been trying to work with that workflow and demonstrate
Hmm.
what a workflow looks like. Maybe
Hmm.
when we have time, I can say a few words about the work we have done. We and see how that work can benefit this work stream as well, or vice versa, right? How we can benefit from this.
Sure, that'll be excellent, David. Yeah, we need to kind of merge different activities and see if we can have a common thread that ties across.
Yes.
Certainly, that we'll take this up, definitely, David. Any other feedback? Any other comments? Okay.
JP, I have one comment.
Sure.
So last time you went through in depth on Mara board activity, but then you barely touched on the last POC package work that you were trying to do.
Mm-hmm.
Um, can you tell us a little bit more about um, what was the idea behind it, and you know
Sure.
how far along you got, and what was the challenge?
Yeah. Okay, that's a good question, Jawad. Let me share my screen and give you a brief overview of what on the package. Yeah, we rushed through last time regarding the package. Right. So just a quick recap. We talked about three different activities, and one of them is the bow interoperability test chip package. Right. So we didn't get a chance to cover a whole lot. We just went through it, glanced through it very fast. And so we can actually talk through it. Still, my name shows up differently. I changed my name. Okay. And so, yeah, this is that interop package that we developed. The layout is ready and ready to actually fab out. So let me talk about what is this package is all about, right? So when we started this activity, the BOW, and there was several people, right? At least I know like 4 or 5 companies are implementing BOW and based on BOW 1.0 spec. But the question in everyone's mind is everybody is developing independently in their own technology and their own process. Can they interoperate? Right. So the interoperability was a big question. Right, and even the companies like Intel or AMD who are heavily into, or NVIDIA for that matter, who are into chiplets, there's nobody has demonstrated interoperability with a third-party chiplet. So we want to take up that as an activity that we want to prove the interoperability of the BOW chiplets developed independently based on the 1.0 spec. And that was the reason why we developed this package. So the two companies contributed at the time, the D-Matrix and Blue Cheetah. They shared their die bump information and a lot of design details, so we can go into the layouts. Right. So this so they based on the netlist they shared and the specifications of the powered requirements, we developed this package, and this package is 40 by 40 millimeter, and it has dies from D-Matrix and Blue Cheetah. I think overall we have about 10 dies on it and different test structures, right? D-Matrix to D-Matrix, D-Matrix to Blue Cheetah in different combinations and lengths, right? So idea of all these test structures, the 5 different test structures, TS1 to TS5, and the idea is to prove the interoperability convincingly, and the BOW 1.0 spec is a viable option, so people can adopt it and integrate it in a like a chiplet marketplace. You buy a chiplet from one company and another chiplet from another company, and you should be able to seamlessly integrate them without any issues. One is there is 2 goals to it. One is to actually prove the interoperability, and the other is if there are any issues, we actually kind of identify them and then come up with a solution so we can actually share across the industry. So those are 2 goals behind this work. And we successfully completed the package development, analyzed the layout for signal, power integrity, and other DFM issues. And the package is actually, as of now, is available in Google Drive and ready for fab out. And we were on the path and to actually get dies from the D-Matrix and Blue Cheetah to test the interoperability. But where we got into challenge was really that funding part, because fabricating this substrate, we have to pay the minimum NRE charges to the ATNS was willing to fabricate this at a substantially reduced cost for ODSA, but we had to pay some initial NRE and develop the boards for the bring up, and we could not secure the funding at the time, and we couldn't, and that's the reason the project got stalled. And um, that's main challenge we faced, actually, especially the projects like this. Developing the design, a lot of people contributed to it. When it comes to fabrication and showcasing it, unlike the Mora board, we got a sponsor, and this one required a lot more funding, and that was a big challenge that we faced.
JP, what was the rough order of magnitude that was needed to do this? Just trying to get an order of magnitude.
The package quote we received from 2 companies is something in the order of about 90K, Akash.
Okay.
And overall, we were expecting, including board and everything, we budgeted something around 250K for the whole demonstration.
Mm-hmm.
JP, so this could have helped Blue Cheetah and D-Matrix quite a bit. If I recall correctly, they independently demonstrated something like this. Is that true?
That is correct. They have their own test board and they have their own chip. They have their own package of this kind, but they put two of their own dies, right? So there's no interoperability, but for their purposes, it worked really well. But the question is, for interoperability, we want to have forum like ODSA, so we can independently take these two dies and showcase the interoperability.
So do you know if they did this thing after they realized that at OCP we are having funding challenges and they just wanted to do it on their own, or do you have any information? And feel free not to answer if you think that's not appropriate.
Can you repeat your question one more time, Jawad?
So when Blue Cheetah and D-Matrix demonstrated that on a package and on a board, they are interoperating. I remember seeing that at some industry event. Were they aware that OCP is doing this effort?
Right. They're very much aware. They actually contributed to a lot of this design information, right? So for the lot of specifications and the design information, netlist, they all contributed. But the challenge was they have to order the dies themselves, and they were expecting ODSA to kind of fund this effort to some level. They will right, not in. They were willing to actually provide the dies, but they were also expecting some level of funding from ODSA. So it will become a collective industry effort to showcase the demand interoperability.
Javad, they did their own, right? Because they're both, Blue Cheetah is a PHY company, so they wanted to test that PHY, so they did their own substrate to test it, right? Themselves, right? And D-Matrix is a product company, so they wanted to test that PHY before including it in their products. So they were going to do that anyway, right? Which they did independently.
Correct. Yeah.
The point here is you wanted to test two different implementations, right? And I think the challenge was the Matrix bump map was very different than Blue Cheetah's bump map. I mean, I remember being on a call and they were talking about all the issues they had, but they were able to resolve those. But this would have been really suitable for just D-Matrix linking to Blue Cheetah to a certain extent, right? Because it was optimized for that. And because they were doing their own, it made no sense for them to even try and fund this, right? And independently, there was no 250K or whatever to do this.
I understand, but just so I have the correct facts. So
there is no D-Matrix to Blue Cheetah interface that's been validated.
Oh, so they never made this package on their own.
Correct. I think that's the misunderstanding. They did their own. D-Matrix did its own. Blue Cheetah obviously did its own, right?
So how were they showing some interop? I recall seeing that. Was that based on board to board communication?
No, there is no interop demonstrated.
No interop.
Oh,
yeah, it's only Blue Cheetah to Blue Cheetah or D-Matrix to D-Matrix, but never, they were relying on this kind of platform to showcase the interoperability. But there wasn't any strong need from their side.
okay.
Yeah, there's a Blue Cheetah board that has been shown many times in public at conferences and things. That's similar to this, but it's an all Blue Cheetah board.
Right.
Unfortunately, this project was before I started consulting with Blue Cheetah, so I don't have a lot of background on it.
Yeah. So I think I'm probably then confusing this with Synopsys and somebody else doing UCIe package for interop.
Yeah, that was demonstrated between, I believe, if I'm not mistaken, I believe it was Synopsys and Intel,
That's
and that
right,
was a public event where they announced that.
Right.
What I understand of that project was that there was still some co-design between the two ends of the connection.
I see.
Okay.
I mean, they were using each other IPs, is it? So
I don't know if I have that level of detail or if that level of detail is public. I would need to check.
I see. Okay.
No, I don't think that was the case. I think they did co-simulate and everything, but they were done independently, as I understand it.
Okay, so JP, today, Blue Cheetah and D-Matrix wouldn't have any appetite for supplying dyes, even if we can find some magical way to get this manufactured, right?
I believe so, Jawad, because that right now everybody's moved on to that next node, right? The next speed evolution. If you're doing this, actually, I don't know if you're doing this exactly the same speed makes sense, because industry has moved on to the next level of speed. And if you're doing it, we should do it at the next level of specifications.
Yeah, I think that's reasonable also. I would need to check in with headquarters at Blue Cheetah to see their interest at this stage.
Right, yeah. So yeah, so yeah, that is actually on the package side, and it requires some more discussion as to we need to evolve. There's a strong need, right?
Yeah.
For interoperability 1.0 or 2.0.
Yeah. So I have a few more questions,
Sure.
JP. So when you designed this package, seems like design is done. Who did the design? What kind of design rule support you got from the manufacturer, and what was the stack up that you picked?
Yeah, that's a good question, Jawad. The design was done by Tessol. Tessol had a packaging team, layout team, and Tessol is a test company contributing to the ODSA. They involved in a lot of ODSA meetings and presentations, and they had a packaging team who helped us on this layout very rigorously. And then Google at the time were also contributing to the layout. There's we had some issues doing interoperable, I mean, connecting between the Blue Cheetah die with the D-Matrix die because of bump map differences. And Google layout team actually came up with a proposal for that. And then in terms of layout rules, we followed ATNS. ATNS was also working with the ODSA. They were very interested. And all this design rules we got from ATNS, and there's all this design is done based on their fab design rules, but it's also kind of generic. We can retarget another fab, but we use them as a kind of anchor point to get this design going. And there was also one more company, I don't recollect very well, Swami. He was also very interested in supporting this for assembly. ATNS will do only the substrate part of it, but we also need to assemble. And Swami was actually was very much interested in supporting this activity from some package assembly and supply chain standpoint. Jawad, do you remember what company this Swami is with?
Yeah, it was that Chinese company,
It
was
was
it
with
JSET?
right?
JSET,
Yeah, correct.
JSET.
Yes,
Yeah.
yeah.
Yeah, so they're now they're calling themselves Chiplet here, I think.
Yeah.
Oh, they changed names or they got
Well, the parent company is Chinese, so they're trying to position it slightly differently. Okay,
Oh,
the
I
same
see.
company.
Right.
Same company. Yeah.
Sadly, we wouldn't be able to work with them that easily. It's just very complicated now.
Mm-hmm.
But how many layers do you recall roughly?
Oh, yeah, 5 to 5.
And what was the line space resolution?
Right, 13 micron width and 13 micron spacing.
Okay.
And it's not a very complicated package, right? If we were to do it today with the UCAE, it'll be much more complicated. And OW is 5 to 5 and 13 micron line width and spacing.
Okay. So I think I have a pretty good idea
Yeah.
of the manufacturing side of what you went through. Did you guys ever talk to any other assemblers such as IBM, for example?
No, we did not.
Or anybody
think-
from Japan? Anybody from Japan?
No, only the ATNS and
Mm,
JSET were the two candidates we spoke to.
okay,
JSET mainly for assembly and ATNS for substrates.
yeah. So, okay, I'd let you finish.
Sure, please.
Yeah, please go ahead.
Oh, okay. Yeah, so actually at this point in time, I don't know, we need to gather interest with this project. If we were to move forward with the fabrication, we need to gather interest for this, right? And what I'm thinking is actually on the where in terms of what usefulness across the industry is what I talked about this project. Right? The test chip bring up project. I had some discussion with Blue Cheetah as well, and they were doing the same, and even the Ilion, they were doing the same, and everybody's doing something similar. They have their own bring up board, and this is I see an opportunity where we can actually kind of define a common specifications. And a single supplier should be able to do independent third-party supplier should be able to design to that spec and open design. And the advantage is everybody can get to share the cost, right? The same design. And then the software would be very rich for testing, right? Where chiplet bring up, chiplet testing, or any other test chip bring up, test chip testing. It becomes very uniform and standard. And a lot of software can be reused. I see a big value in doing this, but every company has got their own way of doing things. But if something there is an agreement,
Yeah, you tried this before. There's going to be no. Everybody says yes, 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 and nobody's going to do this, right?
correct. Yeah. Do you know
Right,
reason?
let's move on with it. I
Kosh?
mean, come on. Everybody already has their own systems they want to use, right? And it also depends on the specifics of the package and the device under test and what your data you want to do.
No, the package is something we can't standardize. Everybody has their own, but
anyway, if this is where we're going, you tried this. I mean, I remember being on call 3 years ago, and you guys were chasing 10, 15 grand each from 10 people or whatever it was, and nobody was interested then. So, I mean, I don't know why we're here then. Okay. Was this the reason, to try and resurrect the testing thing? I thought this was okay. Now let's look at where the market's going and what technology is, and try and go figure out what, how we get some prototypes done, right? So,
do you have any suggestions how we can move forward?
well, no, I just, first of all, I just want to know what it is that people are trying to do. I mean, we've got somebody from CDX who's interested in CDX. We've got, I don't know.
Okay. Mark, do you have any thoughts? We talked about this while back in the con, and I think OCP or something. Do you have any thoughts or?
Yeah, I think well, I still think there's a requirement and a need. I think we're still, apart on the how.
Right.
I
Yeah.
think was Cash's point.
Yeah, but not to develop a test setup, right? I mean, that's, I mean, unless you think there's a market for something like this. I mean, the reality is that if somebody's developing chiplets, they want some sort of a substrate that has multiple chiplets. It's a multiple chiplet thing, and I mean, the only thing I can think of was, and we've been thinking internally about, okay, if we have an FPGA chiplet, and that can interface and make that like a central thing, and then people can put something around it. They can test their chiplet versus and control things from an FPGA. So that was kind of the angle we're going under, but
Correct. Yeah. No, that's perfectly fine, Kash. But
all I'm saying is I was under that impression that this is what this would try to do, is to get
no, that's exactly what it is.
worry about how to test chiplets on a substrate, or work with people like Deca who don't require a substrate, right? They're doing advanced. So that kind of thing is what I'm interested in, right? Not this testing. We'll do a test board.
But there's a practical issue too, right? I mean, we've all been in the chip business for a long time. There's a time that comes when you turn the turn the thing on for the first time, and the green light doesn't come on, and then what do you do?
Mm-hmm.
And how do we debug some assembly of chiplets, right? And I guess more to the point for OCP, how do we validate that a chiplet actually meets the standard that it's designed for? I mean, there is a problem statement in there which is unsolved.
Yeah. So how does this, where you test a single device, right? How are you going to test whether it meets the die-to-die specs?
Well, again, I I don't exactly know. I'm assuming that something like a plug fest is one of the established methods, and the one that's used for USB and PCIe.
Right. So you have to plug it. You have to plug a die, right, into a substrate or some manufacturing technology or something, and then assemble it, right?
And isn't
That's not what this is. This drawing is showing a test hardware harness that's going to test a device under test.
Correct. This what I think, Kash, what you are saying and what I'm saying are really the same. Probably the language is different. We need the problem statement is we need a test infrastructure to whatever be the duty, whatever be the package. We need a common way to test it. Not common way to test it. A common infrastructure where we can put this under test. Right. The question is there a how do we standardize this, and is there would there be an interest across industry to develop this?
Actually, thought on that. It's more of a question. Isn't this a little bit of a two-step process where you design and simulate, and then you build and assemble and test, right? If your design and simulation doesn't work, you wouldn't even go into building it, right? And what I'm thinking is whether the testing framework is even propagates down to the design process, right, where it just goes beyond, right? The electrical part, right, looking at diagrams, one small part of that, right? Even the whole stack about what does the compliance means, right? So that I can design and test. And right, when it comes to PlugFest, right, what patterns I'm sending, how do I communicate those patterns, how do I validate them, right? Kind of have that definition, and then the test setup would just implement that.
Got it. Yeah.
Right.
Yeah, but you're missing the point, right? So if I have, let's say, UCIe from Intel and I have UCIe from Synopsys, right? To die, right? And let's say one of those is a golden die. Let's just use the word golden die that UCIe people use, right? Whatever it is, right? So you have some sort of a substrate design. You put the golden die on one side, you put the other chip on the other side in a substrate, right? Or an interposer or a non-substrate with these wafer panel, whatever the packaging technology is, you put those together and you send data back and forth, right? So that's the most important step, right? So you first say, okay, does this let's say it's because Intel started the UCI, let's say Intel is the golden die, then Synopsys tests and make sure that they can communicate, and then you can actually look at, do you have, what is the bit error rates, and over a long period of time, you can do also change the voltages. You can start doing real characterization work, right, to check out the simulations. So I think that's the fundamental problem that everyone has, right? I mean, I think that's the industry problem, not what I'm seeing on this slide, which is you have a host computer and you have a GPIB Ethernet cable, and that's not the problem. And it's the substrate thing that he was showing, which is the problem.
And what exactly is the problem, the substrate, Kash?
What exactly is the problem in the substrate?
Yeah.
How do you test? As Mark was saying, you're going to do a plug fest. There is no thing you can plug into like a PCIe card, right? If you had a PCI card, then you do a plug fest. In this case, the plug is the substrate or the package design itself, right? Which requires money, right?
Yeah,
And
unless you design it, you can't do the like a plug first. I mean, you can't test the interoperability.
right, because it's a die to die that you're testing, right? It's not plugging into some GPIB or some, socket, right? You have to do the substrate. So the issue is, how do you do that substrate?
Right. No, yeah, I completely agree with you. There are two parts to it. One is actually how to develop the substrate, just like what we did in the previous case, previous slide. And then once you develop the substrate, you have to put on the board to power
Yeah,
them.
but let's not. But you've jumped a step, and what you're showing here isn't the problem. You think it is a problem, but it's not the problem, right? The problem is, how do you get a die? How do you get it, interfaced? What is the pitch it's going to have, right? It's which is challenging, right? What are the rates? That's the problem, right?
No, I agree. There are two parts.
Everybody has ways of having some FPGA or some other system, and let's say they have some PCI connector, well, whatever. I mean, they already have stuff that does this, right, internally, or they can buy or whatever, right?
Yeah, so you think that the people won't move to a common standard for the infrastructure?
There isn't one right now. I mean, people test chips all the time. There is no common, and there is already some common infrastructure that people are already using. That they would, if they do that, if somebody wants to take this now substrate and put it on however they want to package it, they typically will have something in mind, or we can suggest something, or we can just say this is the input, and then they can interface to it in some way, right? I mean, doing a simple PC board, if it's a 130 micron pitch on the back side of that package, is trivial, right? So I think I don't want to see this, frankly, right? Because it's like people just not even understanding what it is the problem that exists in my book.
I think there's many problems that exist, Kash, and you're expressing some of them. But the idea is, how can we provide a path forward for multiple players to enable them to do this in a somewhat programmed way that we set up as an example. And that could well be using this kind of package design or this kind of substrate design. You could plug your die into this substrate and test it out with the golden die, as you called it, the golden die. I think this provides a path. I am not saying this is 100% the solution everybody's going to buy. But what I'm saying is, how do we enable more players to be able to test in some fashion what they're building without going through all the hoops of building all of these pieces? Is there some kind of path forward we can provide to enable more players in this market?
Yeah, so I think we have to figure out, how do we get to a golden die that it's programmable, that would be common across. So let's say that ODSA and Google and said, let's build a chiplet, right? Whatever it's going to cost, $500,000. I don't know what the numbers are, right? Let's go build it. It has let's say UCIe on it, and it has a bunch of wires on it or whatever, right? And that would be ideal so that on different sides you could test different things. And then when somebody has a die or a product they're developing or a PHY they want to test, they could take that golden die and build a substrate or jointly build a substrate or whatever, right? So I think that's a viable approach, right? And you've got to get a PHY vendor to say, but it's not just the PHY itself. For the golden chip, I think you've got to have more than just the PHY, right? You need to actually have some way of sending data into it. You're making sure, as David was saying, that you can send the right pattern. So you now start actually testing and qualifying whether the PHY works, and not just the PHY works, but it's it's viable across a whole range of things like voltage and bit error rate, and stuff that people really want to know, right?
Yeah, so Cash, I have a comment on that one. So building a piece of silicon under ODSA umbrella is probably not going to happen because we had extreme difficulty in trying to get 15K, 20K. The sponsors of OCP are not interested and they don't fund anyone.
Mhm.
There's a misconception that Facebook's gonna come and fund anyone. That didn't happen and probably is not gonna happen. However, if there is a specification that gets developed here for, let's say, a golden chiplet, it can be a fair game for anybody to go after that. And companies that are in the business of plugfest, they would definitely be interested in taking those specs and productizing it. And my suspicion, a golden chiplet that the way you described is a $20 million project. It's not a $500,000 project. So
Well, if the PHY vendors are going to charge full price, I understand. But I think it's appropriate to go and talk to the PHY vendors and say, hey, let's say, I mean, I like your idea of defining, let's say, a golden chiplet test approach, shall we say? I mean, I don't know the right words to describe it, right? And say, okay, this is a spec for, let's say, a potential golden chiplet, and this is what it would be able to do. And maybe, David and team can suggest the type of test that should be. Let's find a way that, we could test this and we can get input from Blue Cheetah on different volts. What do we need to do to be able to test that? If we take Bo as an example, right? What do we need to do to be able to test? How do we drive the traffic through? What do we need on the other side, right? And then I think you've got at least something new, and that this is actually solving a real industry problem. And then if we can get somebody else, right, and we're going to be doing a test chip, maybe we'll find a way to see if we could interface to it or whatever. So I do like that idea. As worst case, just let's work together on what do we need to test, right? What does a golden die need to be, right? What as a wish list maybe, right? And saying, hey, this is what the industry needs, and let's have options for advanced packaging, standard packaging, novel whatever, right? So that it really addresses the real world issues that people are having. Because right now there's no golden die approach, right? I mean, everybody looked at it and said, and maybe it's not viable. It's $20 million, right? But I do think that if we can actually start some kind of process that there is a lot of value for companies to be able to say, hey, here's my die, and as long as I can look at it, we need the golden die company to be willing to share, right, information on its die. Does that make sense? I mean, because there is a competitive element to this too. I mean, Synopsys isn't going to want its UCIe hooking up to a Cadence and them not knowing what's going on. Does that make sense? Unfortunately, there's a competitive element in here as well, which is stopping progress, I think.
So, Kash, I had heard a lot about UCIe trying to do golden chiplet. You know why they were not able to?
I've heard things, but do you know?
I have no idea.
Okay.
Yeah.
Yeah.
I heard that there's like there's 23 different kinds of UCIe out there.
Well, that's its own. You're right. There's advanced packaging and there's standard packaging, but it is possible to design, to have different phi on a die, right? So if your goal was to develop a golden die, right? But John, you're absolutely right. There's going to be different versions of bow, right? We're talking about bow memory, which I think is going to be huge, right? And in terms of people's interest, I mean, I was talking to somebody the other day and they were like, yeah, we love the idea, right? And there's interest in the simple bow for IoT kind of applications. There's people wanting the Allian type stuff, which is higher performance. Maybe they're wouldn't be willing to play game, but all I'm saying is I think that if we could start something along that direction and actually start pulling other people in and say, okay, let's find out how we can do this, and do it in an open way, right? And I think that there's still a chance. I don't know. I mean, I think maybe with bow it's easier because the pinout is fixed, and the bow doesn't change whether you're using advanced packaging or standard packaging or something in between, right? The basic pinout is the same order. So I think it's much easier with bow to develop a golden die than it is with UCIe because the UCI bump pitch for standard and advanced is dramatically different, right? It's
Yeah, I think keeping the pin order same gives us some advantage, right, Cash?
yeah, totally. And there are ways of particularly with like Decca's where they make the links later on, right, which are custom. They could take 50 micron pitch and connect it to something with 20 micron pitch without needing an interposer, right? So I mean, if we could tie into their technology, I think that would also be interesting because they write it at the, what do they call it, adaptive patterning or something, right? So they have that ability.
That's right, yeah.
And they're a U.S. company, so
Gosh, can you say what is that adaptive patterning that you said the US company is working on? What is it? Can you do you know?
I know, yes. I'll see what I can share maybe at the next.
And so I think it's proprietary to what Decca does, and I'm not sure that anyone can actually share it here unless Decca, we call Decca in to present, which is also entirely possible.
Yeah, I think we should do that. I think that they could, and they're seeing, I mean, their technology is being used and set up in Arizona and Florida and IBM, and their previous technology was at ASE, right? So I think that it is a good fit to, I mean, I don't think they would defray the cost of funding it, but they certainly could be very helpful in doing that.
Yeah, and they're setting a partnership with ASU, Arizona State.
Yeah.
And I know there's supposedly CHIPS Act money if that ever comes through. Oh, stop laughing, Cash. Yeah.
I know. So I can chat with Craig there and see if.
Yeah, check with Craig and I can check with them too if they're willing
Yeah,
to.
why don't you reach out to him, and then I can what I'll do is I'll put some thought into a golden die type approach and maybe we can discuss it at the Phi group. I'm in the UK next week, maybe the week after, Anu, and see what the lad thinks and the other guys on the Phi side, and if we could get some buy-in to that concept from a few Phi people, I think that might be a way to try it. And yeah, I think that would be interesting to people, right? So how do I connect to a bow? And even if we did it in a slightly older technology, as long as it meets the specs, it should. And some, let's say you do it in 12 nanometer or 16 nanometer, the golden die, but the other die is in 5. as long as they work, then you now you've got your 5 nanometer chip validated, or 7 nanometer, or 3 nanometer as well, right? So I think that this would be an interesting thing if we could actually execute it.
Yeah, there's always a notion of chiplet sockets, right? Chiplets comes in all sorts of form factors, and integrating them into practical designs is very challenging. And most of the time, we end up doing both chiplets from the same company for that reason. And but just like in boards, we have a common form factors. It'll be good to have a common. There's always an aspiration to have a common chiplet form factors. Right, I heard in a lot of other conferences as well, people talking about this, but there isn't any standard definition, or people couldn't come up with the definition. Maybe one attempt, the golden die you're talking about, can we come up with the common form factors for different applications?
I think it would be great if we could just come up with one application to show something, because right now there's nothing, right? There's nothing in the market, unfortunately. Anyway, so let me. I'll take some action item to at least talk about it, and I'm definitely interested on the Bowflexi side, because that is something we're going to implement as your chip, right? So if we can, yeah, and then I know there's some other people interested in it, but those die will come a lot later, right? So anyway, so I think that is one of the things that's missing is, okay, I have an interface, and how do I connect it to something, right? So I think that's something we can sort of talk about.
Okay. Okay. So Anu, you're going to set a meeting with Deca to explore their technologies, correct?
Yeah, I actually sent a note out to Craig asking if they're willing to talk to the OCP about their technology, and just saying that, look, we're trying to create this proof of concept test vehicle where in theory people could test their chiplets against other chiplets / golden die. And in that conversation, Deca came up. So let's see what Craig says.
Yeah, I know he had some interest in modular packaging, so sort of making.
Oh, did he? Okay, yeah.
Yeah, he does.
That sounds very interesting. Yeah. Okay, I'll stop here and then give it to David. David, you I don't know if we have 10 minutes. I don't know if that's sufficient, but do you want to walk through your thoughts?
How about we do that next time? Because in case there's questions.
Next time with yours, yeah.
Yeah, I don't want to rush, because I really want to, and I also want to understand how what we do is lining up with what we're trying to accomplish here. So I'll probably have some questions too.
Sure, absolutely. Thanks, David. So you would need probably 30 minutes, right?
Yeah, 20-30 minutes.
Okay.
It's going to be a free form discussion kind of thing. So
Sure, we can do it next week. Yeah.
yeah.
Okay, is there anything else, Jawad, Anu, or
Yeah,
anyone?
so JP, I just wanted to enumerate some of the thoughts that we picked up here. So
Sure.
there is interest in some kind of a golden chiplet definition that seems like one aspect, but some of it probably overlaps with other work streams. And the other thought is to explore additional manufacturers for a proof of concept, Deca being one of them, right? And the third one is,
And just to add to that, sorry, modulo packaging, right? Sorry, that's what you want to explore.
right. So, and the third one is, once you have all of these proof of concepts, how do you test them in a plugfest manner, right? Because one big challenge with historical Intel's plugfest was Intel PC was always sitting in the middle that everyone would basically interop with. And when they went to some of the on-the-go implementations of USB, they had a lot of challenges doing plugfest interop. So the plug fest is a multidisciplinary issue. It is electrical. It includes electrical, link, application, and potentially even like in this case, different type of manufacturing, right?
Mhm.
So it is a multidisciplinary and probably a topic that several work streams will touch upon from their point of view. The other thing that is in my mind, stuck in my mind, that should we just try to see if UCIE people are interested in some of this POC? Because the discussions that we are having probably will garner a lot of interest if we also try to bring in UCIE into it. I don't know if that will work, but
Certainly, I think the problem statement is common, whether it's you independent of what 5 we use.
Yeah, no, Jawad, no question. I think it's, I don't know if you want to do it right now or once we've sort of thought more about it and see what the Phi guys internally are talking about. But I definitely think that it would be great if we could do a get some support and an input from the UCIE people as well.
So, Kash, as a next step, so you are going to put together a proposal for golden tie as a starting point. Is that correct?
Together, and then I'm going out of country early next week, so it'll be, I'm not sure I'll be here next Friday, but the Friday after I'll have something on and feedback on that. And then we can share that with, let's see what Craig says, and I can share it with Craig as well, and Anu and team and you, and we can iterate it and get inputs from people.
Sure. Okay. I think that sounds good. And then at that point, we can bring in more UCE people for more feedback.
Right.
yeah, I think we should definitely try the UCIE. We should definitely try more manufacturers. So, ATNS was great. I think I'll reach out to IBM. They have all the substrate and manufacturing in Canada. They're very capable. So I'll at least invite them to come here and present, and maybe we can present to them what we are thinking. But that would be mostly on the advanced packaging side of things, right?
I think it's public that they're also licensed the DECA stuff. I don't know where it is actually in implementation, just FYI.
Yeah, so there's a lot of history with DECA, right? DECA used to be a full manufacturer, then they became an IP provider.
Mhm.
Now they've licensed it to a lot of people, their corrective lithography thing. They're not, to my best knowledge, they are not the manufacturer. So if you write a PO, you wouldn't write
Right.
to
Right.
DECA. It will go to IBM or ASE or somebody, right?
Or
So,
the ASU guys, and there's a Northwestern advanced packaging thing or
right.
something. Yeah.
So I think DECA support will be great. I think since we want to actually do some implementations, it'll be good to see who may have the appetite to potentially give us free shuttle, right?
Mhm.
That's what I would be trying, because I understand asking 90K for thinking that is Facebook is sponsoring all of it. The reality is that's not the case, right? They can participate here, and there will be potential upside for them because it doesn't really cost 90,000. That's with margin, a lot of margin on their end. So
Um,
I'll take that action item to reach out to some of the manufacturers other than DECA.
That's a great idea. I mean, I like you said, it's particularly for something as simple as this, right? I mean, I can understand if it's a lot of layers and it's very complex, right? But it's really going across a few millimeters, right? So, and for advanced packaging, it's just 2 millimeters, right? Or
Yeah.
that. So, anyway, yeah, no, I think that's a great idea.
Yeah, so sounds good, Jawad. And also, Anu, you mentioned that Arizona State University is also working in this area. Is there anybody who can come and talk on what they're doing? Is there any common interest that we can work together? Did we lose Anu?
I think we lost Anu. Yeah,
Yeah.
so they're getting or they have gotten, I don't know what the facts are, about $100 million to invest in. It's the Northwest Advanced Packaging or Southwest, sorry, Southwest Advanced Packaging, right? So at the University of Arizona. And I know that they were putting in Deca's technology, right? So
Yeah.
somebody, I'm sure at OCP has contacts there. I know Anu knows them. So I think maybe just send her a reminder, JP. Just say, hey, would you mind reaching out to them just to see? And I do know that a lot of the U.S. Government primes are also trying to develop chiplets, and they're planning on prototyping things there. So I do think that having a golden chiplet might be attractive to some of those people as well.
Yeah, they're going to have their pilot line is supposed to be up and running in 2026. I can give you the public version of their presentation, the one that they cleared for us to share. Let me just see if I can drop it into the chat, but it describes the pilot line and what they have planned, but it might be good to get on their radar before the pilot line goes into production, because then maybe you could be this idea could be one of the motivators, one of the projects in their pilot line.
Yeah,
Yeah,
I
yeah,
mean, they need to run something through, right? So
Yeah.
they shouldn't expect to you know. So I think that this timing might be very good.
Yeah, this could be a good time to interface them. I just dropped it into chat. You can download the presentation. It says what can be said publicly about Deca, but it doesn't really say much.
Yeah. No, I have some private information too. So
Yeah.
no, that's good. So I think that it's good for everybody to have that. So
Yeah.
Yeah, thank you, John. John, this is interesting.
Yeah.
Yeah, certainly that this path that you're describing is very interesting. They have a prototype fabrication facility, and certainly we should explore that further. I'll send a note to Anu as well.
yep.
So, okay, so I think we are at the top of the hour. So let's close the call and catch up next week. So next week, David, let's start with your CDX flow presentation.
Okay.
And week after next, when Kash is back, we'll talk about the golden die.
Sounds good.
Thank you. Yeah, bye.
All right. Bye.